steel, silicon, graphene. These are not accidents. This is controlled evolution, redesigned by humans. And we call it the materials science. It happened because of two things. First, every species before us evolved as one collective. Bees perfected honey. Birds mastered flight. But humans? We don't evolve as one mind, but as billions of different ones. Each chasing their own ideas, experimenting, inventing, building, all at once. Second, we did something life before us never did. Instead of storing information in DNA, we externalized it. From stone tablets to scrolls, from paper to silicon. We recorded the data in a different dimension. A mirror universe of information. When these two forces combined, things didn't just speed up. They triggered the next era in the materials story. Welcome to the series that aims to simplify our understanding of materials and their science. We are currently in the origin story, and this chapter marks the moment when humans took control and reshaped its trajectory. In the previous chapters, we followed materials from their birth, in the fire of the Big Bang, to the alchemy in the stars, finally, to their strange new destiny on Earth. Across the cosmos, materials change only when the environment allows. But on Earth, life defied all those rules. It redesigned them for its own needs and wants, creating substances found nowhere else in the universe. But this wasn't creation from nothing. Nor was it fundamental alchemy. The game was transformation. Turning the same atoms into entirely new forms. And while that might sound simple, it is the core that defines our material science. The example of Earth and Venus has been instrumental in helping us understand this fact. Similar stardust. Similar beginnings. Yet Venus became a hostile wasteland because there was no life to turn carbon dioxide into living carbon and breathable oxygen. Yes. The atoms never changed. But life did. From simple beginnings to astonishing complexity, billions of species worked across millions of years. Identifying new goals. Reshaping matter, building new molecules, and making new materials. Inventing novel metabolic technologies. Rewriting their DNA, and rewiring the genetic memory. Which is then passed on to their descendants. They perfect it further, or forge something new, from that genetic knowledge. Each generation refining the design. Each evolution solving a new problem. Yes, life was powerful. Creative. Tireless. But, seriously limited in some sense. First, every innovation belonged to a single species. Spiders spun fibers stronger than steel. Mussels engineered underwater glue. Bats and dolphins learned to see with sound. Plants became master chemists, making rubber, pigments, medicines, poisons, even natural sunscreens. Each solution was extraordinary. Each breakthrough, a masterpiece. But, each of them lived and died within the boundaries of its species. Nature could innovate. But, it could not share. Because, all that knowledge lived in one fragile vault. DNA. There were no libraries. No teachers. No memory beyond genes. To exchange information, evolution needed thousands, sometimes millions of years. And when a species disappeared, its knowledge vanished with it. The dinosaurs left us fossils. But what materials did they master? What biological technologies did they perfect? We may never know. From the Cambrian explosion to countless extinctions, life ran billions of iterations. Most of the discoveries were lost forever. Because that data was never saved. Then came the next great pivot. Humans. The hunter-gatherer beginnings must have looked similar to other life forms. Chasing food, shelter, survival. But then, our advancement took a different path. We did not move as one instinct-driven collective. Our evolution could not be coordinated with singular motivations. For each individual had his or her own interests and questions. Satiating survival instincts was not enough. Curiosity fractured us into a billion experiments. Tribes formed around ideas. Groups began to specialize. Some continued with the adventure of the hunt. But many chose to settle down. And along the river banks, a quiet revolution began. Agriculture was discovered. Animals were domesticated. Byproducts augmented. Surplus emerged. And that enabled trade. Trade required coordination. Coordination led to language, symbols, and record keeping. Memory stepped outside the human brain. Transferable. Cumulative. That was the beginning of data. And from data came pattern. From pattern came method. That enabled comparison, planning, and optimization. From practical problem solving to systematic understanding, science began to emerge. This was the real breakthrough. For humans, challenges didn't trigger genetic change. It signaled new iterations of materials and tools. We didn't grow fur to survive the cold. We made clothing. We didn't evolve claws to hunt. We shaped stone. We didn't grow shells for protection. We built shelters, walls, and cities. And that changed everything. Because evolution now had a new engine. Discovery. Invention. Deployment. And it moved faster than biology ever could. Since the solutions were also external, they could be shared. Improved. And even customized. Progress compounded. Stone tools became bronze. Bronze became steel. Steel built bridges, ships, skyscrapers, machines. Clay tablets became paper. Paper became silicon. Silicon now carries the knowledge of civilizations. From boats to steam engines, from railways to aircraft, from satellites to deep space probes, every step was the same story. Across the planet, countless domains, construction, medicine, energy, communication, and many more, began evolving in parallel. Microcosms of accelerated evolution. Pushing the boundaries of possibility, not just for us but for the entire planet. So, to summarize and close this chapter, let's ask again. What really sets us apart? The vision? Or the execution? I'd say neither. They are the after effects. The real cause is our ability to bring curiosity, information, and matter together. As a species, we alchemize knowledge. And if we have to understand the materials and their science in order to bring forth a better future, it is this alchemy that we have to master. And the first step in that endeavor will be to unravel its fundamental structure, which we will attempt in our next video. Stay tuned.